Last lesson in the first semester is talking about the salts. Let's making a small revision for the simple cell. In the simple cell, we study in the preparatory stage when we have two poles, negative pole and positive pole. Negative pole is called the cathode, and the positive pole is called the anode. If we have a salt inside it, this is the solution of the salt Na and Cl, positive and negative. So we'll find the Na are direct toward the negative pole or the cathode, and Cl negative toward or to direct toward the positive pole. So from this we can say that Na Cl positive negative, since it is firstly the positive ion, and this negative ion, since this ion are direct to the cathode, so it's called the cation, and this direct to negative anode, it's called it's the negative ions direct toward the positive pole anode, so it's called anion. These salts are come from the reaction of NaOH plus HCl, giving to us NaCl plus water. So we can say that Na it's come from the base, so it's called the basic radical. And Cl come from the acid, so we can call the acidic radical. The Na is called the metal radical, and Cl is called the non-metal radical. So if we need to define the salts, we can say that is a substance formed from attaching the cation and the anion, the positive ion with the negative ion, the basic radical with the acidic radical. So the salts come from the reaction of the acid and base, or the salts definitions means that substance formed from attaching of the positive ion and the negative ion. Substance formed due to the attach of positive ion and negative ion. What is the sources? Sources of the salts found in the rocks and Earth's crust, may be found dissolved in seawater. Let's talking about the salts according to the way of formation. Salts formation ways. Salts formed due to the reaction. Number one, metal plus acid, like Zn plus 2HCl. ZnCl2, it is a salt, zinc chloride, and the hydrogen gas evolve. Maybe metal oxide plus acid, like FeO iron dioxide plus HCl, giving to us FeCl2 iron dichloride plus water. Maybe metal hydroxide plus acid, like sodium hydroxide react with the hydrochloric acid, giving to us NaCl sodium chloride plus water, neutralization reaction. Maybe metal carbonate or bicarbonate plus acid, like Na2CO3 plus 2HCl, giving to us 2NaCl, and the weak acids formed H2CO3. It is the weak acid dissociated into H2O and CO2, H2O plus CO2. Maybe sodium bicarbonate, NaHCO3 plus HCl, giving to us NaCl plus water plus carbon dioxide gas. It is the sources from which the salts formed. Let's talking about how I can write and how I derived the name of the salts. Derived the name of the salts. Derived the salt name. Maybe the salts come from mineral salts. In this case, like the sodium chloride, NaCl, sodium chloride. So the basic radical is positive, taking the left side, and the acidic radical, negative ion, taking the right side. Sometimes it comes from the organic source. Like a sodium acetate. In this case, we will replacing the firstly start by the acidic part, CH3COO and Na. This is negative part and this is the positive part. So in organic salts we will start with the negative type. What's happening when you have salts have hydrogen? Salts have hydrogen. We called the hydrogen bi, like NaHCO3. So we said sodium hydrogen. In this case it will be bicarbonate. In the case of the salts that have cation salts of more than valency of cation, like iron trichloride or iron dichloride. In this case we said that iron valency of the iron trichloride and iron dichloride. One from the most important steps that we obtain the salts from it, it's called the neutralization. What's meant by the neutralization process? Neutralization process means the reaction which take place between acid and base. To give salt and water. To detect it, we making the process called neutralizations or titration process. We bring the burette. In the burette, we will put the acid, and in the conical flask, we'll put the base, we'll put the base, so acid, and in this case we add the base. Base, it become like the pinky color in case of the methyl orange, pinky color. Then we'll start to add the acid drop by drop over the base, acid over the base, drop by drop, till the colors become colorless. Acid is added to the base till all acid react with the base. The solution color changes to colorless. This point is called the endpoint. What's meant by the endpoint in neutralization? All the acid react with the base. Now we are going to talk about some sources of the salts. Sometimes we will find the salts of the acids, salts of the acids produces more than hydrogen ions, like in the case of the sulfuric acid H2SO4. So we maybe find sodium sulfate or sodium bisulfate. Orthophosphoric acid, orthophosphoric H3PO4 may reduce to us H2SPO4, hydrogen diphosphate, maybe HPO4 bisulfate. In this case it's -1, in this case -2, maybe in this case producing to us PO4, in this case -1, sodium bisulfate, it's only NaH2SO4, -3. Okay, according to the salts we will find it differ according to the hydrogen ion. Now we are going to talk about from where I can determine, and the last thing, from where I can determine that the salt is acidic, basic or neutral. But before talking about it, the reaction of the acid with the carbonate salts giving to us carbon dioxide gas that produced in the form of the effervescence. So when we'll find the reaction of Na2CO3 plus HCl or NaHCO3 in sodium carbonate or bicarbonate, when it reacts with the hydrochloric acid giving to us 2NaCl, water, and carbon dioxide gas evolved in the form of the effervescence in the two cases. Now we are going to talk about the classifications of the salts, acidic or the basic. From where we can determine that the substance or the salts that we have in acidic or the basic. Firstly, we must to determine classification of the strong acid, weak acid, strong base, weak base. Remember them. Strong acid, mineral acid, are most of mineral acids, as nitric acid, hydrochloric acid, sulfuric acid. Weak acid, some more, all of organic. And the most popular one, acetic acid, is CH3COOH, acetic acid or the vinegar. Mineral acid like bicarbonic acid, and also phosphoric acid, which is 3PO4, also phosphoric. Weak base, when having our content is 2 only in H4OH, ammonium hydroxide. And when we have an iron hydroxide, iron trihydroxide, FeOH all 3, iron trihydroxide. Most of the bases are strong, like the sodium hydroxide, potassium hydroxide, calcium hydroxide. And when we have an salts like sodium chloride, ammonium chloride, NH4Cl, sodium acetate, CH3COONA, sodium acetate, ammonium acetate, CH3COONH4. From where I can determine that is the salt acidic or the basics? Pay attention, sodium chloride, ammonium chloride, sodium acetate, and ammonium acetate. Each one derived from the acid and base, so we must divide them into the 2 parts. Firstly, at the first, positive and negative, positive and negative, negative since it's organic, and positive, negative and positive. Then attach it with the hydrogen or the hydroxide. So the positive attached with the OH and the negative attached with H. OH, H. H positive, OH negative, H positive, and OH negative. According to these tables, we will find NaOH, strong base, HCl, strong acid. Strong base attached with the strong acid, so giving neutral. In this case, NH4OH, weak base. HCl, strong acid with the weak base, it will be acidic. The last one, CH3COH, the weak acid. NaOH, strong base with the weak acid, it will be basic. The last case, CH3COH, it will be weak acid. NH4OH, weak base, weak acid and weak base giving the neutral salt. So the end of our semester 1. See you soon, inshallah.